In just 1 month of 2024, we saw 6 named hurricanes. Small errors, big consequences. So the question we explore is, how does satellite weather data actually help build preparedness? Our visualization uses a story-driven approach to guide you through the intensity and evolution of Hurricane Helene. Rather than a traditional sandbox, where all layers are shown at once, we pace the experience so dense data becomes intuitive instead of overwhelming. We begin with a wide view of the globe. As you pan and zoom, you see markers representing rainfall rates at full geographic resolution. This establishes the scale and fidelity of the satellite inputs that forecasters rely on. After the user has traversed a month of the 2024 hurricane season globally, we focus in on the Atlantic Basin, panning the globe scene automatically. Then comes the first interaction. We display a line graph of the first 20% of Hurricane Helene and ask you to predict when rainfall intensity will rise above a threshold based on earlier frames. Most people expect a gradual increase, but the actual spike is abrupt. This mirrors one of the most challenging aspects of real forecasting. Storms can strengthen suddenly. Next, you scroll into a second interaction. Here we place markers at the storm's highest intensity and ask the user to predict the next eye. You can switch between rainfall and wind data while following Helene's trajectory, and start to develop intuition for how multiple features interact. You reveal a predicted path of the hurricane published in real time to the public, and compare the user predicted path to the expert prediction with a score. The final chapter is a resource allocation game, where users are encouraged to use both rainfall and wind data to predict the most heavily affected areas. This further puts users into the shoes of forecasters and disaster managers. Sliders allocate wind and rainfall units, and geographical markers update in response. Controlling the pacing of the story was one of the hardest features to implement. Tying together the position of the page to the frame being displayed on the map required many tracking variables and testing different timings. In addition, we synthesized over 3 gigabytes of data to less than 1 gigabyte, including reprojection. User-driven prediction with controlled pacing invites people to actively interrogate the storm's behavior, and that hands-on exploration forces them to notice how rapidly high-resolution continuous weather features can shift. But most viewers rarely appreciate how much forecasting depends on the quality and timeliness of those observations. Therefore, asking users to make their own predictions becomes a mechanism for revealing why robust data infrastructure is essential for disaster preparedness.